This module is module 6, intersection safety. Um, Again, just to provide background for the Academy, designed to be an interactive experience, giving anyone the ability to successfully determine and solve safety issues on our roadways. And so the key breakdown of it is to understand our mission and the issues that we're facing, understand how to find and use the data, which we primarily covered in the last meeting, module 5, understand our top 3 emphasis areas, learn to be able to solve the top 3 emphasis areas, and what countermeasures are available to us, and then demonstrate mastery on it by actually implementing those countermeasures and seeing, the before after safety benefits. So just zooming out at the entire academy, we're at the intersection safety module. And so that was right after the crash data analysis. And so what we're going to focus on in this training is just how to address safety issues at intersections, being able to ensure we're serving all users at intersections and talking about intersection control, evaluation, and alternative intersections. And so um, for probably just about everyone here today, we either drove, walked, biked, took transit through at least one intersection. Intersections are incredibly complex. I think we forget how complex that they are. And so there's a lot of tools in our toolbox to be able to improve safety and mitigate conflicts, and that's going to be the focus on today's training. I'd also just like to emphasize, as transportation professionals, we love our acronyms. So if ICE wasn't familiar with you, or if I go too fast and say some some acronym that you're not aware of, please feel free to raise your hand and ask. Sometimes I forget all of the jargon that we can use, and just wanted to emphasize that. And so just what we're going to cover today is how to address safety issues at intersections, understand the challenges of being able to serve all users at intersections, thinking through, the countermeasures that are available to us by intersection type, by the characteristics at the individual intersection, and then, understand and explain the benefits of many alternative intersections and walk through the intersection control evaluation and how we think through what would be appropriate for us potentially for a specific location. Again, emphasizing just why we are here today. One life lost is too many, and so we there's about 32 of us, and so amongst the two trainings today, 8 fatalities, 49 serious injuries. Could be someone impacted within this training, or you may have known someone previously who was impacted by either a fatal or serious injury crash. And so just you know the target zero and the vision and mission of FDOT to get there, and that's why it's just so important. And then emphasizing that safety starts with design. I found this infographic pretty mesmerizing, because looking at it, you zoom in and you just see it's an infographic, but you can see like the types of behavioral decisions that people use. You have a cyclist traveling the wrong way in a bicycle lane. You have a pedestrian that seems to be looking down at his phone, and you have a vehicle, with skid marks making a turning maneuver, turning pretty fast. And so um, there's both design and behavioral related to components to safety, and so just thinking through what countermeasures and design we can choose and implement to improve or encourage safer human behaviors. And so first off, I'm just gonna walk through some nationwide intersection safety trends. And so intersecting roadways, just an intersection at its most basic form is critical to provide connections to different routes and roadways and facilitate turning maneuvers and a lot of the transportation. You know, without intersections, we would only be traveling in a straight line, and we wouldn't really be able to get anywhere. And so, with just the complex nature of conflicting movements and intersections, each year, a quarter of the traffic fatalities and half of traffic injuries are attributed to intersections, and that's nationwide. And so really, we're going to talk about like two different types of intersections: unsignalized intersections and signalized intersections. So at unsignalized intersections, which stop controlled, yield controlled, roundabouts as well. They're the from 2016 to through 2020 nationally, 83% of those fatal crashes were vehicle, 14% were pedestrian, and 3% were bicycle. Again, just want to emphasize, you know, what we have generally seen throughout the state as well. 14% of fatal crashes may represent, pedestrians nationwide for fatal crash types. Generally, they're overrepresented. Bicycles and pedestrians are overrepresented in fatal and serious injury crash data. Um, at signalized intersections, we have an increase in pedestrian bicycle in terms of fatal crash percentages. And then there's a breakdown that are attributed to red light running for vehicles, which is 27%, and then a bigger bucket for other. Again, intersections are incredibly complex. There's a lot of potential for mistakes that humans can make there, and so it's really difficult to attribute it to just one thing. There's a lot of little decisions that go into as you travel through an intersection. Looking some statewide comparisons, Florida is at the top of the number of intersection fatalities, and so it's incredibly important to think through intersection safety. It's been over 1,000 fatal crashes at intersections since from 2017 through 2021, and California and Texas are up there too, though a little less. Um, and so that was just a nationwide overview. And so now going to get into a little bit more Florida specific intersection statistics. There's been a lot of great work in the state safety office and central office to break down these statistics using the crash data and available that we learned in module 5. And so unfortunately, there's been an increase in fatalities from 2015 through 2019 at intersections. It's been a 27% increase with a slight decrease in serious injuries. And so what we're seeing is that intersections, are a challenging point. And so that goes into the next slide, which is the FDOT's Strategic Highway Safety Plan. And so the FDOT SHSP has these different categories to help address intersection safety based on crash trends. And so, you may be familiar with the 4 E's: engineering, education, enforcement, and I think fourth E is emergency response. And so it also includes some additional categories, including information and intelligence, innovation. On the next slide, we see insight into communities, understanding the community's needs and surrounding areas to get more context-based oriented solutions at intersection, and then also thinking through investment and policies. And so this is intersection safety is really a key piece to the FDOT's SHSP. And so there's been a lot of work already done with root cause analysis. The root cause is basically trying to figure out, what is the primary cause of of crash trends. And so I'm just going to go over just a brief overview of what is it, and then kind of walk through how it's so challenging to really apply that to intersections. Um, and so root cause is just trying to, again, what I mentioned is trying to figure out a wide range of approaches, tools, and techniques to uncover the main cause of problems. And so, this approach has been taken by the State Safety Office on lane departure, pedestrian and bicycle, and intersection crashes. The other modules are going to cover those types of lane departure and pedestrian and bicycle in more detail. But ultimately, the goal is to inform target zero, to think through what approaches can be used to address these root causes. And so some of the analysis that's done is about 20% of the factors cause about 80% of the issues, and then nearly 80% of the factors focus on about 20% of the issues. And so really, it seems like a little paradoxical, but what that means is we're just trying to identify the factors with the most risk and countermeasures to maximize the results with the limited resources. Because, again, unfortunately, there's no unlimited funds. We live in a system that's constrained, and so we need to basically do the most with the limited resources. And so some of the outcomes of just the root cause analysis was just identifying safety countermeasures and funding opportunities, and strategically inform future and ongoing safety initiative. Um, but one the main thing that came out of the intersection analysis is that there really is no one root cause. You have so many different types of intersections. You have a 6-lane intersecting with a 4-lane. You have a 6-lane intersecting with a 2-lane, unsignalized two-way stop control. All of these different, once we get into the alternative intersections acronyms for those, it's really challenging to find a single root cause. Like, even thinking through just a signalized intersection, you have potentially different phasing alternatives as well. And so there's just so many variables when it comes to intersections that it's really difficult to identify one root cause. And so the next slides are just going to give a more high level break, or a more detailed breakdown into what we're seeing within Florida. But unfortunately, there's not just one I guess smoking gun when it comes to improving intersection safety. There's so many different types and characteristics. And so I just want to emphasize that you know it really takes a whole team, a whole organization to think through these solutions. Is not just limited to one office within FDOT. Really, all of us as transportation professionals really need to think through these challenges, and come up with solutions. And so just within intersection safety in Florida, I just wanted to reemphasize that it's one of the emphasis areas in the Florida Strategic Highway and Safety Plans. Um, from 2017 through 2021, there was about 4,500 fatal crashes that occurred at intersections, and about 35,000 serious injuries. And so that's in a 5-year span. And that's those one life lost is too many. And so there's a lot of work to be done to improve intersection safety. Statewide within Florida, it's almost 40% of all fatal and serious injuries. And then that's about at intersections. I know on the previous slide we walked through just what's going on statewide, but at intersections, that's 3 fatalities per day, and 19 serious injuries per day, and it's caused by a variety of different factors. Potentially aging road users, distracted drivers, motorcyclists, pedestrians and bicyclists. There's really a lot of components to intersection safety, including the types of users, and also the actual infrastructure and that's out there in roadway and intersection design. And so again, just for from so that was 2017 through 2021. This slide is 2018 through 2022. It's a similar number of fatal and serious injury crashes. Breaking down into some of the data that we had mentioned in Module 5 is 90% are occurring at dry road surface conditions, 10% at wet, and then 61% daytime, and about 40 percent either dark and lit, dark or unlit, or other lighting conditions. And again, these are statewide averages for this time period. That they can fluctuate, and every unique intersection in sight is different. And so I just wanted to reemphasize that these might be um, you know okay thresholds to use, but really it really depends on the specific location and the characteristics. And so and also the number of crashes, because if you have two crashes, that really doesn't give you the big picture. So you want to make sure you have a large data set when you're thinking through these potential intersection countermeasures. And so the crashes commonly occurred Thursday through Saturday at intersections, and generally in the afternoon conditions. Looking at the vehicle maneuvers, it's a mix that fatal and serious injury crashes occurred. Angle and left turn are about 40 to 50%, which thinking through the vehicle speeds makes sense. Surprisingly, rear end is 15%, which you may not expect, and we're going to go through potentially why that may be happening. 5% head on, 7% fixed objects then run off road, and about 30% other, which includes pedestrians and bicyclists. And then just again, some high level statistics. 26% of those are occurring at signalized, 74% at unsignalized, 76% at urban, 24% at rural. And so a lot of these more serious crash types are occurring at unsignalized intersections. And then just thinking through, the intersections on the state road, there's a lot of different types of intersections. You'll have the state highway intersecting a state highway road, a state highway with an off-system road. And so in terms of intersection types, a majority of the crashes are with the state highway intersecting an off-system road. 40% are an off-system road and off-system road, so just statewide. There's also you know a lot of crashes occurring at non-state highway system facilities, and then 4% state highway and state highway roads. And so these statistics were just meant to provide just an overview of the challenges that we may be facing at intersections, and the specific crash trends for fatal and serious injuries. And I'll pause here briefly if there's any questions or comments before, jumping into specific countermeasures for different types. Seeing no questions or comments, and so we'll jump into countermeasures, which is going to be taking up a majority of the rest of our time for this module. There are a lot of countermeasures, and understanding that not everyone is familiar with all of them. It's just challenging to be familiar with all of them, just because there's so many, and as the industry is increasingly innovating, there's more and more innovative countermeasures. Nathan.
Yeah, so this isn't an exhaustive list of countermeasures, but they are some of the more popular ones, and a few of maybe the marginal ones. It's kind of like a CMF clearinghouse, right? Like understanding what you can do, understanding what options are out there, um, and kind of how you can start to do some of that address. So the conversation is probably going to be a little bit boring without any interaction. So like I said, there may not be logical stopping points. So if Spencer's coming to a countermeasure that you have more questions about, like how does this work? What does this do? How should I apply it? Just go ahead and raise your hand or speak up. We don't have a lot of people talking over each other, so even if you just wanted to unmute and speak, I think that's fine. If you want to be more polite, go with the hand raise. We'll get it. But yeah, I mean, this is it's great for this to be interactive. By all means, this is probably the best chance to get a lot of people in a room together and talk about it. If you are having the question, somebody else is. So if you ask it, everyone else is going to benefit from it as well.
Thanks, Nathan. And like Nathan mentioned, we're going to be focusing on, this is not an exhaustive list, and we're going to be focusing on the FHWA Gold Star intersection countermeasures. It's a very long list. It's meant to be interactive, and again, a lot of these come from the CMF Clearinghouse, and so CMF, just for those of you who aren't familiar, stands for Crash Modification Factor. There's been a lot of research both within the state of Florida and nationwide and internationally on, before after studies for these countermeasures to quantify the benefits of them. And so, we're going to be talking through specific countermeasures and the percentages, of crash reduction that we're seeing for different crashes and injury types. Ben, I see you have your hand raised.
Yes, not to jump ahead, but I haven't looked at the CMF clearinghouse. Are these all focused on single countermeasures, or does it contain some combined?
So I think these are, I think the research within the CMF clearinghouse is primarily focused on single countermeasures. Once we start to like layer them, it becomes a little bit more difficult to measure. And so a lot of these are focused on single countermeasures, and then we can get into more details. There's some engineering judgment, as always, that needs to be applied when you're trying to layer them and quantify, the benefit cost analysis potentially. And Nathan, I see you might have something to add.
Yeah, part of it depends on how the study was done, right? So like if you look at curve safety, and we'll look at that when we get to the lane departure module, you start getting like, adding chevrons, where there were none. But then you'll get one where it's like we want to add chevrons, we want to add sequential dynamic curve warning system, and we want to add transverse rumble strips. And there's a study that did all of that and they put it in there. So there are some countermeasures that have multiple in one. But when you start to get multiple, if we think back to Tuesday's conversation, that's when we start to get to multiplying CMFs. Then you got to make sure that when you're doing multiple CMFs, right, you're looking at making sure they are consistent in the type of crash they address and the consistent in the severity of the crash that you address. Um, and then you are tentatively multiplying the CMFs, the crash modification factors, not crash reduction factors, because that does not work. You're doing the CMFs to getting with a maximum of 3. But if you remember also the new NCHRP that's coming out, that's going to it has recommended language for HSM2, that they're now saying just take the not the most conservative, the strongest CMF that you have and apply it by itself, regardless of how many countermeasures you're using.
And again, that's a lot of like technical details about, CMF. We're not, if there are questions about it, we're happy to answer them and how to apply it for, a benefit cost before, after. But the main purpose of this is to make everyone aware of the intersection countermeasures
Ooh, I
out
made
there,
$38 on it last
and
year. Month.
and what they may be. And if you have any specific questions as we go through them that you're not familiar with, it's a pretty long list. I'd also love to hear, from personal experience about anyone's effectiveness or challenges with implementing some of these. And so I'm not going to read off all of them on the slide, but there are kind of different categories that we're going to be focusing on. And so we're going to be focusing on unsignalized intersections, signalized intersections, at signalized intersections, geometric changes, phasing changes, and also we're going to be focusing on alternative intersections, and then there's also going to be a focus on low cost countermeasures for implementation as well. In addition, to the FHWA Gold Star countermeasures, I'd also just like to reference the FDM and the TEM. There's a lot of great information there at intersections, talking through some of these specific countermeasures and the applicability of them on state roads. And I know probably the speed management module is going to cover that some more in some more detail, but there's already a lot of great resources within FDOT on when certain types of countermeasures are applicable, and also the studies that need to occur in order for them to be implemented. So this is also just a continued list on these countermeasures. Again, there's intersections are so complex that there's a lot that we can do, and by no means is this list exhaustive. There's also outside of the FDOT, maybe in different areas, and unique challenges, thinking outside the box for potential alternative solutions may be warranted. And so, to understand what countermeasure we should implement, or countermeasures, we really need to understand the safety issue at an intersection. And so, looking through, just a question I'd like to ask the group is what causes safety issues at intersections? And I have a picture of a pretty complex intersection, and so just want to see what everyone thinks of what potentially can cause a safety issue at an intersection like this, or just any intersection. Lori?
If there's visibility issues with cars blocking the visibility of other cars when they're turning or need a turn with different angles and stuff.
Yep. Julia?
Things like high speed, or for example, in this intersection, the crosswalks are really long. So that would be really difficult for a pedestrian to fully cross. I'm supposed it could be signalized in a certain way to make it more evident, but yeah, visibility, especially with the right-hand turn and that conflict with pedestrians or cyclists. Yeah.
Yep. That's great. Billy?
Oh, sorry. Timing. So people don't feel pressured or rushed in an unfamiliar intersection, like when it turns yellow.
Yep. Yeah. Yellow change, red change intervals as well. Anyone else?
There's some answers from the chat, including distractions, malfunctioning signals, speeding phones, confusion, people from out of town.
Yep. Yeah, that's great. Thanks, Brianna. And thanks everyone for the answers. One of the key things at intersections that we're going to be talking about is conflict points. And so, thinking through turning maneuvers, how many lanes that are needed to cross. You have a conflict point at potentially each lane. Great things that were mentioned, like speeding and poor sight distance. Also thinking through conflicts between road user types. The crosswalk length was mentioned. Also visibility of pedestrians, potentially, being obstructed as they're crossing halfway by different vehicles. The presence of right turn on red and red light running, aggressive, and I think, Billy mentioned a good point. Potentially delays at the intersection could contribute to aggressive driving behavior as well. We also have, complex locations like this throughout the state where there's a bus pullout right after the intersection, causes some conflicts and friction too. And so when we talk about conflict points, um, we want to reduce the severity of conflicts between all road users types. So that includes vehicle to vehicle to bicycle, vehicle to pedestrian crashes, and reducing those conflict points. And so this is a diagram when we talk about conflicts, just all of the different types of conflicts that are out there. And so, as you're driving through the roadway, you have a diverging conflict as you're making a turning maneuver, making sure, you're not, this is potentially, a same direction sideswipe crash. And then as you go through the intersection, you have a crossing conflict because you're intersecting with another lane of travel, another potential crossing conflict. And those crossing conflicts are usually where we see more severe injury types because they're higher speeds and more of that, T-bone angle maneuver. And so just at this intersection, there's a lot of conflict, a lot of conflict points. And all intersections are pretty different with not only the geometric characteristics but also the types of users that we need to serve. And so there's not a one size fits all strategy for these intersections, and it really takes looking at the challenges holistically and the existing geometry and potentially signal phasing and understanding the road users. And so some of the things that we look at an intersection is the importance of signing and pavement markings. And so making sure the crosswalks at all signalized intersections, the crosswalks on state roads are the standard is for them to be special emphasis, making sure the turn lanes are marked. Here we kind of have an intersection that's a little bit offset. And so we have lane line extensions to facilitate, people going through, knowing that they kind of have to turn a little bit to make sure that through maneuver we have, bicycle lane markings. But we also have instances where, the bicycle lane in this case, it drops at the intersection, or there's some conflict points here. And so making sure, thinking through serving all users at the intersection. So in addition, to signing at the intersection, we also in addition to pavement markings, we also use signs at the intersection. And so I just wanted to ask the group, what signs do we frequently see on an intersection approach? Billy?
Yield for pedestrians on right turns.
Yep, and just there's I know you mentioned yield for turning vehicles, yield for pedestrians. There's been recent guidance that the turning vehicle stop for pedestrians is appropriate at signalized intersections in the state of Florida. There's some language in the TEM, but yeah, I think that's you'll often see those signs at dedicated turning lanes. Lori?
No U-turn signs?
Yep, you'll have instances where there's, restricted turning movements, including U-turns. You'll also have U-turn, yield to right turn signs, which is as a driver, that's one of the more challenging, conflicts. That's well, personally, one of my least favorite things to do is when I need to make a U-turn, there may be an overlap phase or something, and I have to watch out for right turns in addition to opposing traffic. So yeah, that's great. Anyone else? So in addition to a couple of the signs mentioned, also street name signs. Those are throughout basically all intersecting roadways in the state. So alerting drivers to what road they're approaching. We could have next signal ahead or intersection ahead signings. Identifying the cross street. Bicycle lane signs, pedestrian crosswalk signs, depending if it's in, the intersection could be in a school zone, school zone signing may be appropriate. And so there's both, I just want to emphasize we're already talking about a lot of pavement markings, a lot of signs to enforce, enforce and encourage the driver behavior to improve the understanding of the intersection. we're driving and using these facilities, there's a lot that we need to quickly digest to understand what the appropriate movements we need to make for wayfinding. And so there it's just re-emphasizing that it's an incredibly complex situations that we're dealing with. And so that was just kind of a high-level overview of the conflict points at intersections and more of the philosophy behind just the complexities there. And so specifically now we're going to get into unsignalized intersection strategies, and these countermeasures are going to be focused on geometric changes. And so one of the geometric changes is roundabouts. We're going to get into the addition of turn lanes, modifying the skew, angle, access management, shoulder width, medians and pedestrian crossing islands, and improving the site. So some of the challenges that you all already mentioned, these countermeasures are going to address. And so one of the gold star countermeasures is roundabouts. And so converting a stop controlled intersection into a single lane roundabout, and even a signalized intersection to a roundabout. And so what a roundabout does, it really reduces the total number of conflict points. It slows vehicles down at entry. And so when you're getting into instances with a high prevalence of angle and left turn crashes at either a two-way stop controlled intersection or even a signalized intersection, potentially a roundabout could be a good alternative. There's also constraints with roundabouts, which are primarily with the required space that they take, so they may not be the best solution. And later in the module, we're going to get into the intersection control evaluation that helps us determine the appropriate alternative intersections that we should be considering. And so also the additional of left turn lanes. When you think about an unsignalized intersection, you're traveling along the roadway, and you need to make a left turn. Without a left turn lane, you're going to be abruptly stopped. That puts you at risk for potentially a high speed rear end. And in addition, making that left turn could be challenging. And so maybe you feel uncomfortable, you feel pressured, and so you accept a pretty aggressive gap in vehicles, and so that could put you at risk for a left turn or angle crash. And so installing left turn lanes can provide a total crash reduction ranging from about 30 to 50%. There is guidance out there for when we should be considering left turn lanes on an unsignalized intersection, and then if we want to get into the details, it's a variety of turn lengths and queue storage need to be provided based on the speeds as well. And so curb extensions are also a great solution, both at unsignalized and signalized intersections. Lori, I see you have your hand raised.
Yeah, question. So for the left turn lane, that's at an unsignalized, but it could be at a signalized intersection. What is the unsignalized? Is it when it's just everybody can go straight, but then the people that want to turn left, they have like a red or something, and they have to
No,
yield or something?
No, so when we're talking about unsignalized intersections, I'll just say generally throughout this module, we're referring to two-way stop controlled. And so, the state road would be, free flowing. And then the minor street, potentially a local road would be stop controlled. And so basically we would be adding a left turn lane on the state road so you would be able to move over. You would be able to stop and store in that left turn lane until there's a gap versus maybe slamming on the brakes. Someone behind you puts you at risk for rear end. And so that's what we mean at left turn lanes at unsignalized intersections. They're also can be effective at signalized as well. There are different volume thresholds when they're applicable at signalized intersections. There's also you can get a little bit more I guess, creative with phasing. There's some phasing alternatives you could potentially consider there as well. And we're, one of the things to consider at more so at signalized intersections is as you begin to add turn lanes, thinking through, what that change causes to the intersection footprint, and what that means for pedestrians and bicyclists. It could increase their crossing distances. Could make it more challenging for cyclists to move through the intersection. So there's there could be potential trade-offs of these countermeasures to be aware of as well. And so curb extensions, what curb extensions are, I think they're pretty self-explanatory, but you're extending the curb at an intersection, to reduce crossing distances, and also they're effective in reducing turning vehicle speeds as well. And so this is, this figure to the right just shows before after. And so there's already some on-street parking, so the space isn't being well utilized at the intersection. There's, I guess, you could potentially call it a little bit of dead space. And so installing the curb extension, it better aligns the driver turning movement. And so instead of making a higher speed, potentially fast turn, they cut this curb radii. They make a slower turn, more likely to be able to see pedestrians in intersections, or pedestrians and cyclists at the intersection as well. And potentially there could be some operational benefits, both to bus operations and even to reducing, pedestrian flashing don't walk times. Nathan? You're muted, Nathan.
Glad you mentioned operations. So something I was gonna point out as well is, I mean, really, friction is what causes operational issues, right? Because essentially, if you had a perfect model of vehicles driving down the road, you'd have a train. So you can go bump. That's like the whole CAV idea of being able to go bumper to bumper, right? And so when we're dealing with congestion, a lot of that comes from intersections. And you have a signalized intersection, especially if you're, like, say, in an urban area with a lot of pedestrians, your signal operations are drastically impacted by the length of time a pedestrian has to cross the road. So, if it takes you 15 seconds to cross versus 30 seconds to cross, that's 30 seconds or so, two pedestrian crossing cycles, right? 30 seconds total that you saved in your cycle length. And then you're also looking at some of the requirements in MBTCD is looking at all red times. Making sure that you're accommodating, especially when there's a bicycle signal. But if you think about if bicycles exist anyway, we should be doing it. Extending the all red time to account for the extra time it takes for a bicycle to clear the intersection. So when you start looking at these massive intersections, not only is it safer to keep it smaller, but there are some efficiencies that you can get as well by making smaller intersections.
Yep, and there's also, we're not going to get into the details, but at signalized intersections, you could also introduce things like two-stage crossings, and so pedestrian goes halfway with another left turn phase. There's efficiencies that you can build in with curb and median extensions that reduce pedestrian delays and potentially reduce vehicle delays as well. And also, so we could be seeing operational and safety benefits. And so this is just a picture of, a curb extension was installed, and it effectively, this is a protected intersection as well. And so there's enough space at the intersection to extend the curb and provide a protected intersection, which allows for basically two-stage bicycle left turns. We're going to get into that countermeasure on a future slide. Again, another potential benefit of curb extensions is, the potential for placemaking. And so you can introduce, art features, public paintings. And again, I want to, there's different types of curb extensions. You don't need to be constrained with, just extending it with concrete. You can see here that this extension, they're using vertical delineators, and so this could, you can potentially have a short-term solution to install curb extension with delineators, and then as a future project is programmed, potentially install the curb there. And again, each location and jurisdiction is very different in terms of their wants and needs, and no location would be the same. So another countermeasure is to modify the skew angle. This can be challenging and costly, but it is can be a significant benefit at the intersection. And so basically what you're trying to do is it's easier to facilitate turning movements when it's at a right angle. And so once you get less to 75 degrees, you want that to be more of a right angle. It improves the sight distance at the intersection, and also driver expectancy with being able to know that, oh, you continue straight through versus needing potentially offset lane line extensions and things like that. And so another geometric benefit is modifying allowed turns. We talked about access management a little bit previously, but changing a corridor to right in, right out access, and identifying a location along that corridor where you want to facilitate U-turning movements or left turning movements can significantly increase the safety at that individual intersection. And then at those intersections, at multiple intersections throughout the corridor, you're going to see safety benefits along the segment. And so this one kind of blends because the access management would be along for the segment, but the specific countermeasure would be at an individual intersection. Another countermeasure is raised intersections. It slows vehicle speeds, providing vertical deflection, and so it improves driver yielding to pedestrians crossing at locations, especially at unsignalized locations. This is a pretty unique instance where you have the main line is still two-way stop control, so this is free flowing, but you still have a crosswalk, and so drivers yield to they're more likely to slow down and yield to pedestrians. And again, this condition may not be seen on the state road. It may be pretty rare to see a roadway like this on the state highway system, but raised intersections can be applied on the state highway system, and are a good potential alternative, or good potential countermeasure. Again, we kind of already mentioned access management, but it's also applicable to signalized intersections. So thinking through more of the corridor, reducing driveway density can reduce total crashes, especially in more rural area types. And then also it can reduce fatal and injury crashes, because with access management, if you reduce the number of driveways, you're reducing the number of conflict points along a corridor. And so thinking through, is there any driveway consolidation that can be done? Again, it also depends on the context of the facility. Maybe in a more, thinking through C4, C5, C6, you're going to have a high frequency of driveway densities that may actually, reduce speeds. And so thinking through, the access management may not be applicable to all corridors in context. Lori, I see you had your hand raised.
I just had two thoughts. One was the question of what is driveway density, but it sounds like it's like just fewer driveways, like area, like in locations, or
Yeah, so
and then
for driveway density, it's just like the frequency of driveways. So maybe you have 100 driveways per mile, and if they're all open access driveways, can there be any consolidation to reduce that on a corridor where there's challenges, to a lower frequency, to reduce those number of conflicts, and basically you're trying to reroute the vehicles within those developments at more of a single access point. And so maybe, once that occurs, maybe they could meet signal warrants or other things.
And as Ben said before, like not trying to take the engineering judgment out of it, it's also context and speed dependent. Because just like street trees with driveways aren't as big of an issue at lower speeds in different contexts. Because if you think about like a lot of our suburban issues, we have where subdivisions have tapered down to almost no network at all. And you deal with high speeds between it, you deal with traffic concentrations, like if they don't quite get the signal warrants, things like that. So it is very dependent. Driveways can be in some ways a safety, I hesitate to say this, but some safety feature with really low speeds, in the sense that you're creating friction. So just keep in mind it's dependent. Like if you're 45 miles an hour plus, reduction of driveways is almost always a good idea. Once you start getting down, you start getting in different contexts, it starts changing. With Florida Administrative Code 1497, so 1496 was just done. I think Jenna Bowman has 1497 on a to-do list. I don't know that we're getting to it right away, but it's somewhere in there. They're looking at changing from the access management classifications to bringing it in line, from what my understanding is bringing it in line with the context classification system, which is kind of acknowledging that you have like a speed and context differential there.
Oh.
Was there anything else, Lori?
Yeah, thank you. Do people have a right to have a driveway access, or if they did at one point and there was construction and it was on a state road? Do you? Yeah.
I got this one. So people have a right to reasonable access. They do not have a right to actual access. What I mean by that is, as long as you can provide safe and reasonable access to a state road, it does not have to be directly on the state road. So side street access counts as that. If you've gotten, let's say there's a developing parcel and you've managed to secure cross access easements to the adjacent property owners, then if the new person comes in, I do not have to give them access to a driveway. I can say you're going to take your access through your neighbor's parcel. Once the permit is issued, if we don't go with the political side, if we just stick to what's legal, the department can legally modify any permit, period. Once you start modifying to a point, then they have a right to seek an administrative hearing. And in the administrative hearing, it talks about what's going on. The department defends what they're doing. There's some requirements, for instance, with like modifications of driveways that allow you to do that. And in safety issues, once again, legally, if you have a safety issue, you can drop Jersey barrier across the driveway. Now, I've only heard of one instance that ever happened, and it was moved in like an hour. But from a technical legal standpoint, safety trumps all. And then when it comes to the access rights, while you do have access, what that access looks like is negotiable. And side streets count, other driveways count, different stuff like that. So they're also not required for the type of access. It just has to work. Trying to think through some of the other explanation. If you want to really get into that, I think it's either Florida statute, it's either 338 or 335.1. I think it's like 0.08 to 0.88 or something like that. And then, but 1496 and Florida Administrative Code 1496 and 1497 have all the access management stuff. 1496 is, I believe, the rights, and 1497 is, and plus permitting, and 1497 is the access management spacing standards. But they'll also represent you to the appropriate place in the Florida statutes, because that's where they get their authority from.
Thanks, Nathan, for providing that additional background. We have a lot to cover. We're a little bit behind, so I'm gonna try to pick up the pace a little bit. But still, like, please, if you have questions, please, feel free to raise your hand and interrupt me. And so some additional unsignalized intersection strategies: full width shoulders, install medians, pedestrian crossing islands, and improve sight distance. Again, a lot of these strategies do not need to be they're not only applicable at unsignalized intersections, they can also be applied to signalized intersections. And so now we're going to get to just some other strategies. And so thinking through like stop ahead pavement markings, some low cost countermeasures, conflict warning systems, RRFBs or rectangular rapid flashing beacons, lighting, additional, stop signing on both sides of the roads, and recto-reflective sheening on signposts. And so this is what the stop ahead pavement markings look like with the signs. And so at unsignalized intersections where you're coming up to a stop condition, these can be effective in reducing crashes. This specific location is within a curve, so it's challenging to see. Can't even see the stop sign in this picture, so really alerting drivers ahead of time that they need to slow down. Potentially, this could be paired with additional countermeasures like transverse rumble strips at the area to we begin to stack them to reduce or to improve driver awareness. Again, these countermeasures are relatively low cost. In addition to the pavement markings and signage, you could also there's this something called a bright stick, which there's potential to put on signposts. So at night, the signpost really lights up. Can't remember if it's on the approved products list, the APL, but there are there are countermeasures out there that can improve nighttime visibility. This one is relatively a new countermeasure. It includes things like intelligent transportation systems. So you're getting into things like ITS at still unsignalized intersections. And so what this is this is warning vehicles on the main line that there is a vehicle that just entered the roadway from a side street. And so really trying to get you to be aware and slow down. And so you're not having that angle conflict. And so this has a 55% or more crash reduction. It's relatively new, and it requires like ITS in order to be able to detect that vehicle entering from the minor street, flash that warning sign on the major street to alert vehicles. And so RRFBs at this, now we're talking at intersection / mid block, the line can begin to blend, but this is to improve the driver visibility of the crosswalk and pedestrian within the crosswalk. There is guidance within the TEM and FDM on the applicability of RRFBs. And typically just at a high level, you would want to do it at priority bicycle and crossing routes, and or where driver yield rates are low to improve those driver yield rates. In this picture here, it includes bicycle pavement markings in addition to the pedestrian pavement markings. There is some challenges with installing RRFBs at intersections with driver yielding behavior to sites due to side streets and the visibility of the RRFB there. So there may be potential variations needed that central office would need to potentially approve to install this at an intersection. And so in addition, like previously mentioned, lighting the intersection, especially with the prevalence of nighttime crashes, adding additional stop signs on both sides of the road, and potentially, adding retroflective sheening on signposts, or, the potential for bright sticks on the posts themselves can improve that nighttime visibility. And so just wanted to pause for, an interactive. So I just wanted, we went through a lot of countermeasures. So can anyone tell me, what countermeasures have been applied at this unsignalized intersection location.
The signage for pedestrian crossings and also the left turn.
Yep, left turn. So installation of a left turn lane, pedestrian crossing signage, additional, signage that left turn lane must turn left. And so those are a few of the things. Again, you have this intersection is also still, challenging because you have, potential access point here, potential access point here. And so while some countermeasures have been already installed, looking at the safety data, the unique characteristics of the intersection, is there anything else that may be needed? And so it's not, it's there you get a lot of unique instances like this that really cause you to think, and also, you could potentially put in, a spot median here for pedestrians as well. So there's, even within a location that's already been improved, there could be potential for additional improvements. So now we're going to transition from unsignalized intersections to signalized intersections. The first, I guess, chapter that we're going to be talking about, or section we're going to be talking about, is operational countermeasures. And so really thinking through the signal timing phasing. If you're not familiar with some of the nuances in signal timing, just again, feel free to ask questions. It can be a little complicated or overwhelming if you're not a signal expert. And so this is just a long list of the countermeasures. So we're going to be talking about leading pedestrian intervals, or LPI, some exclusive pedestrian phasing, bicycle signals, and some other protected phasing and coordination that we can do at our signal systems to improve safety. And so first off is the leading pedestrian interval. It's a gold star countermeasure. It gives basically pedestrians a head start in the crosswalk to cross before turning vehicle movements. And so you can see here that pedestrians have the walk symbol with the adjacent street being red. Generally, it's between 3 to 7 seconds. I think the TEM allows for a maximum of 10 seconds of LPI, depending on the characteristics of the intersection. And so while this doesn't reduce or doesn't eliminate the conflict with turning vehicles, it separates pedestrians and vehicles both in space, because you're getting a head start and in time. And so that's some of the benefits of LPI. There's also been, statewide analysis done about the operational impacts of LPI, and they're pretty limited for most cases, but there's already been research and analysis conducted on that. And so separate to LPI, there's exclusive. Oh, Ben, I see you have your hand raised.
Yeah, on the previous one with the pedestrian leading pedestrian interval, does this indicate that there's any increase in rear end crashes when it's installed, or is it pretty benign in that regard?
I don't. I guess the short answer is I don't know. I see Nathan shaking his head no. And so they're
traffic's already stopped when the LPI is
Right.
going.
Right.
So
Thanks.
yes, there shouldn't be any increases in rear ends. There's also some challenges. So the TEM has some guidance with signal phasing. If you're running a protected permissive left turn, most likely you're going to want to lag it, or even a protected left turn, just to avoid late turning conflicts while pedestrians get a head start. There's also guidance now that, whenever LPI is installed, the need for accessible pedestrian signals. And so we have, our visually impaired users are aware that they're getting a head start versus having to wait until they hear the vehicle go. And so we also want to make sure, we're serving not only pedestrians, but all potential users, and the visually impaired as well. And so an exclusive pedestrian phase, it stops all vehicular movements and allows pedestrians to cross. So I will caveat this slide that, there's an exclusive pedestrian phase, which could be on all four legs. And then what's shown in this picture is a scramble crosswalk. And so those are similar, but they're a little bit different. And so an exclusive pedestrian phase is, if imagine, this green crosswalk was not here, it would allow all roadway users to cross. They would have, the walk and flash don't walk time. And generally, pedestrians would only be allowed to cross at that time. It reduces, turning movement conflicts. It removes pedestrian vehicle conflicts due to turning movements. I will caveat that there's still human behavior. Sometimes pedestrians, they'll walk when outside of the time they're supposed to walk, but it does eliminate or reduce that conflict. This is a scramble, and so a scramble is now you're adding in that diagonal crossing as well. And so depending on the intersection geometry, if it's a very wide intersection footprint, it may not be operationally or safety beneficial to add in that scramble, just because you're adding a lot of time to the cycle. So again, these are complex locations with complex considerations. And so it also depends on the need for, our pedestrians, wanting to make a diagonal movement, because it reduces the need to cross in two stages. And so a crosswalk like this may not be, applicable depending on the lane use and context of pedestrian movements, but it is a good alternative to reduce those pedestrian vehicle conflicts and crashes by 35%. And so bicycle signals, they're relatively new as well, can make operations clearer at intersections for cyclists. And so we can get into phasing where we're providing for a bicycle through movement and holding a vehicular, right turning movement. So, a keyhole bicycle lane is not necessarily needed. You can shift the bicycle lane to the right of the right turn lane and provide for a bicycle signal. And so it's another good alternative, especially paired potentially with protected intersections. Flashing yellow arrow is also relatively new within the nation and the state of Florida. And so you change the left turn phasing from protected permissive to protected permissive with a flashing yellow arrow. And so instead of, the 5-section signal head with the green permissive ball, you have, generally a 4-section signal head with this flashing yellow arrow. There are, some phasing benefits when you can omit this phase if you're having a conflicting pedestrian phase. It also reminds drivers that they proceed left turns with caution versus, the permissive green ball may be a little misleading or confusing to drivers, and it's a 14% reduction in left turn crashes. This is new. There's a lot of challenges with implementing this for the local maintaining agencies of the signal system. And so when you're thinking about this countermeasure, it's good to coordinate with them as well. In order for it to be implemented, it also potentially needs a structural analysis for the mast arm. But we're seeing more of these requests for flashing yellow arrow analysis and implementation throughout the state. Lori, I see your question about D4 bicycle signals at intersections. I am not sure. Katie, I'm not sure if you know of any.
I mean, until I saw this presentation, I didn't know they were a thing. So I don't know if anybody else on the call has any experience with that. But on the yellow flashing arrows, just so everybody's aware, that is something that we do get a lot of complaints on. And coincidentally, like as we're sitting here, someone just complained on US 1 thinking it's making it unsafer because people are, making decisions maybe when they shouldn't be. So that is one that, the municipalities and traffic ops really have to analyze well.
I will say one of the dangers for the yellow flashing arrows is because you can change whether it's protected. Like the benefit, right, is that by itself, it is not the safety measure. The protected phasing portion is the safety measure, right? So it's contingent on it being timed for the right times. The idea being when it's super busy, when you're having um, the crash issues and the conflicts, that you can have it protected. And then the times of day, like say the middle of the night when no one's out there, you can make it permissive so it's not an issue. The problem with them though is that when you start getting complaints, you have to be strong on your decision making and keep it protected. Because it's very easy when you have that up versus a 3-section head, it's very easy to start kind of cheating with when it's protected versus it's permissive, so that you can push more people through if you haven't had a crash in a while and the crashes pick back up again. So that's one of the downsides of the flashing yellow arrow, and something you got to be careful with.
Yep, and there is guidance within the TEM on conducting that study and applicability, but again, it's we have pretty unique geometric instances, and it may not be applicable to all locations. And Lori, just following up about bicycle signals, I think there's one. I think on Miami Beach in D6 there's I don't know if it's been installed yet, but they've been talking about installing a bicycle signal on the state road, and that's the only one I'm familiar with within South Florida on the state highway system. So another gold star countermeasure is no turn on reds, and so eliminating pedestrian vehicle conflicts for those right turning vehicles. For implementing LPI and exclusive right turn phase, you can implement a blank out sign. And so I'm not sure if y'all are familiar with a blank out sign, but it's basically an illuminated sign, kind of similar for the ones at railroad crossings. When it says like no left turn, in this instance it would be no right turn for when the pedestrians for when the LPI or exclusive pedestrian phase is in use. That just reinforces drivers that there's something special is going on versus potentially just having a static sign. So we mentioned this, Billy mentioned this previously about the yellow change interval, adjusting the clearance interval times for the appropriate conditions. There's standards within the TEM, and so making sure that the yellow change intervals are appropriate to avoid any yellow traps or red light running. And again, coordinating with the maintaining agency of the signal system to make sure they're accurate. There's been instances when doing safety studies and reviewing the intervals, updating the yellow and red clearance interval based on the TEM guidance. And so that's always important to